In this video, we're going to discuss some basic math problems you'll see in the fire protection world. If you want more real-world applications of these problems, feel free to check out FireTech's courses that discuss basic math applications and fundamentals at our website at firetech.com. So for the first problem, we're going to find the area of a rectangle. Let's say it's a floor plan of a room. We're trying to find spacing for sprinklers in this room. So let's go ahead and see what the dimensions of this room are. So the longest side of our rectangle is going to be our length. And let's say this room is 12 feet long. Now, the shorter side is going to be our width. And let's say this is 8 feet long. So, given these values, we're going to find the area of our rectangular room. So, area equals length, or L, times width, or W. So what we'll do is we'll plug in the values we found, 12 feet, let's write that down, times 8 feet. Now when you plug that into a calculator, you will find that this area is 96 feet. But it's not just feet because we're multiplying 2 feet together, so it's going to be feet squared. So the area of our room is 96 feet squared. Okay, now that we found the area of a rectangle, let's say we want to find the volume of a rectangular shape. So here we have a rectangular shape. In this case, let's say a tank. So a water tank for a system. So we already know that the longer side is going to be length. And let's say the length of this tank is, again, 12 feet. And we also have our shorter side here is going to be our width still. And that's going to also be 8 feet, like in the last problem. But now we have a new dimension added right here in yellow. This is our height. So that's what makes it 3D. We have 3 dimensions. The new one being height. Let's say it has a height of 4 feet. Well, now in order to find the volume, it's similar to our area equation. However, we are going to add this height factor. So we're still going to multiply length times the width. And now we're also going to multiply that by the height. So again, let's take these values and plug those into the equation. We have 12 feet times 8 feet times 4 feet. And when we plug that into a calculator, remember in our last problem we had the 96 feet, but now we're going to multiply that by 4 and get a value of 384 feet. But wait, this isn't just feet because we're multiplying 3 feet together. So it's feet cubed or cubic feet. So 384 cubic feet is the volume of this water tank. Okay, I'm getting sick of talking about rectangles and boxes, so let's move on to a new shape, which is triangles. So triangles are going to be similar to rectangles and boxes, as they will also have essentially a length and a width, but they do use different terms when finding volume and area of triangles. In this case, we're going to be finding the area of this triangle. Again, this could be whatever you want it to be. Let's say it's a triangular shaped room. And our longest side of this triangular shaped room is going to be called the base. So similar to length, but in this case, it's the base. Let's switch up our numbers and say it has a base of 10 feet. So, in addition to a base, we are also going to find what's called the height of a triangle. So I'm going to use H for height. So the height's going to be that top point down to the base. Sometimes you'll get triangles that look like this. So their base and height are pretty easy to find. In this case, we have what's called an equilateral triangle, and it's going to have that height going from the top to the bottom. So we just added it in for show. But that height, let's say, is 5 feet. This will be an easy math problem then. So you may just think, oh, well, it's just going to be base times height, right, to find the area of this triangle. Well, triangles do have a little special equation to them, as we're going to take half of the base times the height. So the reason for that is when we look at this triangle right here, we see it's essentially half of a rectangle. So see, it's broken into two. So that's why we have that half factor in this equation, as if you have two triangles together, they'll make a rectangle, leading to that just base times height equation. But okay, let's plug in those values to find A. So A is half of 10 feet. Oops, I forgot my multiplication sign, so I'll add those in real quick. Times 5 feet. Now this is a little easier to solve than those other equations, as we have just 10 and 5. So half of 10 we know is going to be 5. So essentially you're just multiplying 5 by 5. So our area here is going to be 25 feet. What? Feet squared, because we have those 2 feet in the equation. So not all problems will be this simple. I just happen to make it simple. But definitely check out, again, some of FireTech's courses, as we'll have more applicable problems to solve in the real fire protection world. Okay, we have an entirely new shape. No corners on this one, as we're going to be finding the area of a circle. So the area of a circle has its most unique equation we've been dealing with in this video, as the area of a circle is pi times the radius squared. Now, what all does that mean? Well, let's look at this practice circle, for example. So first we'll touch on what pi is. Pi is a constant value that is always going to be equal to 3.141. It goes on for a lot of numbers, an infinite amount of numbers to be exact, but in our case, we've rounded it to just these 4 digits. So, given that information, we can now say our equation is 3.141 times the radius squared. Well, what the heck is the radius? Again, looking back at our practice circle, pretend this dot is right in the middle of the circle. So this is our center point of our circle. The radius goes from that center point to the edge of the circle. You can also say the radius is half the diameter or the full length of the circle. So if you're ever given the diameter equals 9 inches, you'll know that the radius, again, is half the diameter, so it will equal 4.5 inches. Again, it goes from that center point to one side where the diameter reaches the full length of the circle. Okay, so let's take a problem, for example. We're given this circle and we're told that the full length of this circular room, per se, is equal to 20 feet. Again, some easy numbers for us. So we know that the full length of the room is 20 feet and we're asked to find the area. Well, the radius is half the diameter or full length of the room. So that means our radius is going to be 10 feet. So plugging that value into our equation, again, we're going to use 3.14 instead of saying pi, and then we're going to multiply that by 10 feet squared. When we simplify this problem, we know that 10 squared is going to be 100. And then we'll consider our decimal point here in this 3.14. Since 100 has 2 zeros, we're going to move that decimal point to the right 2 times. So 1, 2, giving us an area of 314.1 feet squared. Although we didn't have pi squared or pi in feet, we know that it's squared because the radius was squared. But that is the area of this room, 314.1 feet squared. There you have it. There are some basic math problems. Again, check out Fire Tech's courses for more in-depth problems like these that you can apply to the real world of fire protection, along with some other helpful equations in that course as well.